Hello everyone, this is Saurish Mitra from Sri Venkateshwara College of Engineering. I'm a first year student pursuing BE in Computer Science and Engineering. Today I'll be giving a presentation on the subject mathematics and the subtopic is integral calculus. Agenda of this topic: Introduction, type of integrals, definite integrals, indefinite integrals, summary. Introduction. Integral calculus is a branch of mathematics that deals with the concept of integration and the study of antiderivatives. It is one of the two main branches of calculus, the other being differential calculus. Integral calculus primarily focuses on calculating areas under curves, finding accumulated quantities, and solving problems related to continuous change. Types. There are two types of integrals: definite integral and indefinite integral. Definite integrals. A definite integral is a mathematical concept that represents the accumulated quantity between a function and the x-axis over a specific interval a, b. It is a function of calculating the assigned area under the curve of a function within a given interval. The result of the definite integral is a numerical value that represents the net area between the function and the x-axis over the interval. Mathematically, the definite integral of a function f(x) over the interval a, b is denoted by a, b of f(x) dx. Here f(x) is the function being integrated, dx represents an infinitesimal change in the x-axis, and a, b specifies the interval over which the integration is performed. The definite integral can be interpreted as the net area between the curve of the function and the x-axis. If the function is above the axis within the interval, the area is considered positive. If the function is below the x-axis, the area is considered negative. The net area is algebraic sum of these positive and negative areas. The fundamental theorem of calculus is a key result that connects the definite integrals with the antiderivative indefinite integral of a function. If it states that if f of x is an antiderivative of f of x on the interval a, b, then the value of the definite integral is integral of a, b fx dx is equal to the difference between f of b and f of a. Integral of a, b fx dx is equals to f of b minus f of a. This theorem provides a practical method for evaluating definite integrals by finding the antiderivative and then evaluating it to the endpoints of the interval. Definite integrals have numerical applications in mathematics and various fields of science and engineering. They are used to calculate quantities like area, volume, work, displacement, and other quantities that involve accumulation over a specific interval. Next is indefinite integral. An indefinite integral, also known as antiderivative, is a mathematical concept that represents a family of functions whose derivatives are equal to a given function. It is an integral that does not have any specific limits of integration, unlike a definite integral. In other words, finding the indefinite integral of a function f(x) involves finding a function f of x such that f of x is equal to f of x. Mathematically, the indefinite integral of a function f of x is denoted by integral of f of x dx plus c. Here f of x is the function being integrated, dx represents the infinitesimal change in the x-axis, and plus c represents the constant of integration. The constant of integration accounts for the fact that there are finitely many functions whose derivatives are equal to f of x. The constant of integration is crucial because when the taking derivative of constant, it becomes zero. Therefore, adding a constant term allows for the inclusion of all possible solutions. Different functions that differ by a constant term will have same derivative, which makes sense because the derivative doesn't capture information about the vertical position of the function on the graph. When you evaluate an indefinite integral, you end up with a family of functions that have same definite f of x but can differ by a constant shift. This family can be represented by the general form f of x plus c, where f of x is the specific antiderivative of f of x and c is the constant of integration. Indefinite integrals are used to find the solution to various problems involving accumulation of quantities, growth, decay, and other situations that involve the concept of rate of change. They play a key role in solving differential equations, which model many real-world phenomena in science and engineering. To find antiderivative of a function, various techniques can be used such as integration by parts, substitution, partial fractions, and more. However, it is important to note that not all functions have elementary antiderivatives expressible in the terms of elementary functions like polynomials, exponentials, trigonometric functions, etc. And in some cases, the antiderivative might involve special functions or cannot be expressed in closed form. To summarize the whole topic, integral calculus has a wide range of applications in various fields, including physics, engineering, economics, biology, and more. It is used to calculate quantities like area, volume, and displacement, and solve problems involving accumulation, growth, and decay or motion. Thank you for being there for in this video. Please do like, share, and subscribe. For more content, please subscribe to this channel. Thank you.